Plastics 2021 gives you insight into new injection molding processes for your designs, as well as continuing to simplify and streamline the setup process. It is now possible to access the material databases prior to creating a plastics project. This release has added nearly 400 new materials from global manufacturers. A number of existing materials have been updated and reclassified, with some discontinued materials removed. The material library features enhanced display of viscosity and pressure volume temperature plots, and polymers can now be searched for by their density. The algorithm used to generate solid meshes from sketch-based runner system has been enhanced to create more realistic shapes of runner cross-sections and runner junctions. The mesher now applies tetrahedral elements at the core and prism elements at the boundary layer, improving convergence and result accuracy. Co-injection processes feature enhancements allowing ABA sequencing, as well as the ability to specify a delay between injections. This is also available for gas assist and water assist processes. A new injection molding process is available to accommodate multiple material overmolding. This manufacturing process is perfect for parts like this that require a soft protective covering molded over the rigid plastic, but can also be used on parts requiring injection of up to 6 different materials within the same cycle. You can now also fully define your analysis before meshing is required. This starts with selecting the materials for each injection process. For the first injection, one of the new ABS materials will be used for the main body. The second injection process will use another new material, which is a thermoplastic for the soft protective cover, and is selected from the recently used list. Once the material for each injection process has been specified, you simply need to apply the material to its associated domain. In this case, the ABS to the part body and the TPE to the overmold geometry. Plastics makes it easy to define other critical elements in your plastic analysis as well. For instance, you can define cooling channels without the need to physically model the mold. 2021 significantly improves your simulation results by creating more realistic baffles and bubblers within these virtual cooling channels. All you need to worry about are the specifications for each type, which include parameters like the OD, height, and the thickness of the blade in the baffle channel, and the ID of the tube in the bubbler channel. You'll see how these new changes impact the mesh shortly. Like the cooling channels, you can define a runner system and a virtual mold, allowing you to analyze and look at multiple scenarios for your injection process before investing time and energy into designing and modeling the complex components of the mold itself. All of these domains can now have their materials applied to them prior to any meshing taking place, allowing you to fully specify the components in your plastic injection analysis. Other critical design elements, such as the injection locations, can also be defined directly on the 3D model without the need for meshing any geometry. By referencing the geometry itself instead of the mesh, it saves time setting up different design scenarios as well as automatically updating when the 3D model changes. All of the boundary conditions in the plastic study can be defined in this way. This includes other design elements such as the cooling channel inputs and outputs, as well as things like the clamp force direction. The entire plastics analysis has been defined geometrically and virtually. This makes the file on the disk smaller, portable, and more adaptive to change. Eventually, when you do mesh the model in preparation for the final simulation, you will immediately see the benefit of those improved baffles and bubblers defined earlier. They are now fully meshed and modeled appropriately, giving you more accurate simulation cooling results without the need to fully model the cooling channels and the physical components that make up those special inserts. By defining the entire simulation on the 3D model and the virtual domains, it has enabled a more dynamic workflow where you can look at and evaluate different scenarios in your design before any of the heavy lifting is done. The results themselves, which include the new multi-material overmold injection process, are now more accurate when considering cooling, giving you confidence in your injection molding process before you even start designing or investing time and money into the mold itself. SOLIDWORKS Plastics 2021 closes the loop on the geometric-based boundary definition approach started over the past couple of releases and simplifies the simulation setup process. This, along with the vast new library of materials and the new multi-material overmolding injection process, will change the way you evaluate your plastic injection molded designs.